Welcome to the lecture series on vitamins and nutrition. Today we are going to discuss about vitamin C's physical and chemical property. But before we go with the details of physical and chemical properties, we are going to look at the overall function of vitamin C, the sources of vitamin C, and a little bit note on the historic origin of vitamin C. Although today we are not going to look into the details of the historic development of vitamin C, we are going to study more into physical chemical properties, and probably in the coming sessions we will look into how this vitamin was developed as a fundamental nutrient supplement. Today we are going to go through what exactly this vitamin C is all about. We know it's a water soluble vitamin, it's a very strong reducing agent, and that's one of the reason vitamin C is being used as an additive in food industry, not only for its nutritive value, acting like an antioxidant in the food supplements that we take. In addition to that, vitamin C has this inherent strong reducing property which actually helps in the preservation of food. That way, all foods fortified with vitamin C have dual advantage. One, it acts like a nutritive supplement, and also it helps in the preservation of food. So we are going to look at how this particular vitamin C is going to perform its function. We are going to slowly go through the details of how vitamin C is able to do it. So you see here, vitamin C has this capacity to be reversibly oxidized to dehydroascorbic acid. So this word, antioxidant property, it's a very popular terminology, and we have seen before the fat soluble vitamin E is also exhibits antioxidant activity. And if you look at vitamin C, there are many metabolic processes that occur in our body that involves proton transfer, and vitamin C is extremely essential in such reactions. Now, if you look at different kinds of minerals that are essential for uptake, and for example, if you look at iron, which has to go through the gastrointestinal barrier, and vitamin C is very good, very useful in helping in the absorption of iron. Say for example, if you have to look at one more vitamin, especially the formation of folic acid, especially the activation of folic acid into its nutritive form, involves vitamin C. So in that way, vitamin C is very useful, not only in its own right as a water soluble vitamin, but its role is essential for other vitamins as well. And if you look at vitamin C specifically gets concentrated in certain tissues. Say for example, in pituitary, in adrenal glands, in eyes, in platelet, and in WBCs. And that's one of the reason we use vitamin C as a prophylactic in preventing viral infections. So it's a very good suggestion that all the physicians make, especially for people who have this propensity to fall sick because of common cold virus. They recommend vitamin C as a food supplement. The normal vitamin C they take, it's recommended for them that they need to take it on a regular note so that the incidence of viral infection can be brought drastically low. In fact, research says that almost there is an 8% reduction in adults in the occurrence of common cold, and almost like more than 10% reduction in the occurrence of common cold. So probably if you look at the accumulation of vitamin C in immune cells could be a role, because immune cells will be essential for not only for the membrane development of all the essential cells, especially when immune cells are under attack by various components released from the pathogens, and you also need to quickly replenish all the membranes which have been damaged in the normal combat between the immune cells and the pathogens. So vitamin C has many essential roles to play. So the one example what I have shown here is just a highlight of the function of vitamin C. In addition to that, there is also a study which has shown vitamin C supplementation drastically reduces cataract formation. This is again a reason how vitamin C accumulation in eyes could be justified. Now if you look at the historic background of vitamin C, although I have mentioned this in earlier sessions about clinical trial methodologies applicable to vitamin, I always mentioned about vitamin C's historic study. The first clinical trial for food supplement was conducted for vitamin C, and it was by Captain Lind we saw. And you see over here, this is an example how we have more sailors who were killed by scurvy than compared to all the sea battles the sailors had to undergo in the early days of exploration. It's such an essential vitamin that many of the sailors who had to travel very far, so it was very early days when exploration was taken, there was no sophistication of mariners and the equipments that they had, so it was all an adventurous move. So people had to struggle a lot, and supplement with vitamin C was available only through fresh fruits. And you know very well, as sailors in the early days of exploration did have limited rations, and they had very little advantage of being refilled now and then in special ports. So that was one reason why all the sailors, most of them, were prone for scurvy. So this discovery that vitamin C supplementation from citrus fruits was a real breakthrough, the way in which the sailors' health could be recovered fast. Even in those days, it was not exactly an association with vitamin C, but they could always associate an ingredient in citrus fruits that was responsible in the cure of scurvy. Because vitamin C structural elucidation and systematic study started way back only from 1912. Here is one example. You look at this picture where you have 4 species that lack vitamin C synthesis, and man is one among them. Okay, he is one of the mammalian species who cannot produce vitamin C. So capybara, bat, guinea pig and primates. So that's one of the reason where we have this important message that dietary supplementation of vitamin C is very important. Since we cannot make vitamin C of our own, we are totally dependent on the diet that we take. And as you know very well, vitamin C is thermolabile. So the way we prepare the diet, and especially if you are going to look at how the diet is being made from natural sources, would help in the contribution of vitamin C on a continuous basis for every one of us. So you see here, the daily requirement of vitamin C is 60 milligrams. So we have to also look at, this is just an average value, the RDA value, and the need for vitamin C can be more in times of pregnancy, lactation, and in especially conditions connected with convalescence, when people are recovering from sickness. So if you recollect, I told you earlier, one of the Nobel laureates, Dr. Linus Pauling, he promoted the administration of vitamin C as an antidote for aging and also to boost immune responses. So he had done a lot of meta studies, and he himself personally was supplementing with 1 gram of vitamin C every day. There have been many studies done to corroborate the findings of Dr. Linus Pauling. Although there was mixed opinion and results, overall everyone agreed that supplementation with vitamin C, especially for people who do have vacillating immune responses or probably who are prone for viral infection, can be benefited by the supplementation of vitamin C. The exact details of whether they have to take 1 gram or just 200 milligrams of vitamin C is still a topic to be settled, with more research studies needed to confirm specifically with different population. But everyone agrees most of the general physicians who practice always agree that vitamin supplementation, especially vitamin C, really helps people fight viral diseases. And we are going to go further now into the pathways in which ascorbic acid could be synthesized from glucose. So, you need 4 enzymes to make vitamin C. It's the uronic acid pathway, where glucose would be the raw material in which vitamin C could be synthesized. But this particular pathway is not there in mammals, especially with primates, which we have already seen in the earlier slides. So, look at this picture. This gives you an insight of how glucose gets converted into ascorbic acid and then further into dehydroascorbic acid. So, if you look into the backbone structure, so this is the typical glucose molecule. Can you see the changes that happen over here? You find an hydroxy group. This hydroxy group has been replaced by a keto group, and there is no change over here in this hydroxy methyl hydroxy group. And here you find there is a double bond. So, you also see here there is an additional hydroxy group. So, you see the structural transformation from a glucose to an ascorbic acid. There is hydroxylation, and here there is carboxylation. So, an hydroxylation and a carboxylation results in the formation of ascorbic acid. Now, this ascorbic acid undergoes oxidation, and you see over here there are hydrogen atoms removed from both the hydroxy groups. The keto group remains. So, you know the definition for oxidation and for reduction. Either removal of hydrogen or addition of oxygen is called oxidation. In this case, in oxidation of vitamin C, you find there is removal of protons, which is depicted in this structure as dehydroascorbic acid. So, ascorbic acid oxidation results in dehydroascorbic acid. And when you are going to reduce it, so what is reduction? Reduction is addition of hydrogen. So, in this picture, when hydrogen goes over there to this keto group, you get back the hydroxy group. So, this is a kind of reversible reaction where ascorbic acid, when it participates in free radical scavenging or when it is going to show its antioxidant activity. So, summarily, this is the kind of reaction you could expect in the tissues. So, we have the first 3 enzymes. Since humans and primates cannot synthesize, okay, so this particular enzyme is L-gluconolactone oxidase. So, in this glucuronic acid synthesis, you find the UDP glucuronate, which is getting converted into one of the raw materials which has been used by microorganisms, the proteoglycans, glycosaminoglycans, glucuronide. All these are structural components of microbes and also being used by different organisms. So, this UDP glucose basically comes from UDP glucuronate comes from UDP glucose, and here you have an enzyme UDP glucose dehydrogenase. Now, this UDP glucuronate further becomes glucuronate and finally it ends up as L-ascorbate. So, you look at this picture, the glucose 6 phosphate basically comes from glucose 1 phosphate, then you have UDP glucose which acts like a kind of intermediate, and there is pyrophosphorylase that removes the phosphate group, and here you have the UDP glucose pyrophosphorylate, you have UDP glucose, and this is the kind of a reaction that you could expect in glucuronic acid where L-ascorbic acid is produced. we do not have this pathway active in terms of producing vitamin C. Now here is the summary of the pathway where D-glucuronic acid gets converted to L-gluconate and finally to L-ascorbic acid. So you have the dietary supplement where you have the xylitol being formed from L-glucuronate via the pathway of decarboxylation, where we have L-xylulose which becomes xylitol, okay, and then finally the D-xylulose gets phosphorylated to form D-xylulose 5-phosphate. So this particular enzyme, L-gluconolactone oxidase, so this particular enzyme is absent in primates and guinea pigs, and because of this we are not able to form L-ascorbic acid from L-gluconate. So this is basically the D-xylulose 5-phosphate which enters the hexose monophosphate pathway. So this particular enzyme is not there, so we are not able to make ascorbic acid, although the majority of the pathway is still operational in primates. So where do we go for the dietary supplement? Since we cannot make vitamin C and since we lack the particular enzyme in making vitamin C, we are dependent on fresh fruits and vegetables. So you see there is a plenty of choice for us. You have red pepper, lychee, papaya, strawberry, orange, lemon, melon, all the citrus family. They are rich in vitamin C. See, citric acid should not be confused with vitamin C, although I would say the flavor wise they might have resemblance, but both are totally two different compounds. Both are acidic in nature, that's true, but citric acid is a tricarboxylic acid, whereas ascorbic acid is derived from glucose. Just now you saw the structure. In ascorbic acid you have a keto group on the chain, and the hydroxy group is also oxidized to give you the keto formation. So you have a summary picture. All the colored vegetables, they are rich source of vitamin C. We have already seen the colored fruits and vegetables are also a rich source of vitamin A. So this picture tells you most of the vitamins you find in these colored fruits or carotenoid, or you have vitamin C as one of the fundamental ingredient. So you do have other vegetables, cauliflower, garlic, grapefruit, and the seasonal fruits like mango and pineapple. Most of these fruits, if you look at, are a combination of fruits from the tropical sources as well from temperate regions. So you have a combination of variety of vegetables. Only criteria is that most of these vegetables have to be taken raw. In other words, in a properly cooked fashion where you don't damage vitamin C. So excessive deep cooking will obviously destroy vitamin C. And taken in a fresh format, there is a good chance that all the vitamin C in the corresponding food can be directly consumed in a fresh format. That's one of the reasons what people found in the early days of associating scurvy with vitamin C deficiency. People failed to look at this important point, and it was accidentally discovered that only fresh fruits and vegetables are able to cure scurvy, and through that people were able to associate the role of some ingredient in fresh fruits, and now from this side of the history we know it is vitamin C. So you look at, for infants the daily requirement is 35 mg and in adults it is 60 mg. As I have been telling you earlier, this dosage reflects only on the average intake, because every individual would definitely have times of stress where the demands from nutrients would be high. So in such cases the amount of vitamin C taken would also double. And you look at a case like pregnancy and lactation, there is always intake of vitamin C, need for intake of vitamin C increases by 20 milligrams and 40 milligrams respectively. You know very well, because in pregnancy and lactation, the simple logic is that the new developing fetus would need additional vitamins to support their growth. So the only way by which they could get their food nutrition is through mother's diet. And that's one of the reasons why women are recommended to take additional quantities of vitamins and obviously the relevant nutrients which would really help in the development of fetus. Suppose if these nutrients are not properly supplemented, this will directly have an impact on the development of fetus, and that can lead to lots of congenital anomalies and deficiency related conditions very early in the children. We are looking at this picture. So we have already seen this picture but in a different format. Now we saw in the cyclic format, this picture gives you how vitamin C, ascorbic acid, can be converted to dehydroascorbic acid, and you see there this proton are being removed and you have consecutive keto groups. So this reaction of oxidation and reduction is reversible. So it's the same picture, but I am repeating the slide so that we will be able to have a mental picture of how ascorbic acid gets converted into dehydroascorbic acid. Can you count the number of carbon atoms? So 1, 2, 3, 4, 5, 6. So that's why we said it's a compound which comes from hexose, glucose. So you do have a 6 carbon, and in this the 4 carbons form a cycle with the oxygen over here, and this particularly the hydroxymethyl group forms the side chain. Now there is a compilation of the functions that we are associating with vitamin C. We have already seen that vitamin C acts like an antioxidant. Its role in the hydroxylation of proline and lysine, important amino acids that forms the part of collagen. Then you do have the role of vitamin C in steroid biosynthesis, and you have catecholamine synthesis from tyrosine, which is an important neurotransmitter, and vitamin C is also involved in bile synthesis, and this also we have seen earlier how vitamin C has an impact on the absorption of iron. So you could say if a person could run short of iron supplement, it could be a dietary depletion of iron. Although the person might be taking iron rich food, there could be a reason why this iron doesn't go into systemic circulation. So supplementing with vitamin C would very well improve the bioavailability of iron. So any iron rich diet, if you are going to supplement with vitamin C, the bioavailability of iron can be greatly increased. So this is an important point to note. For people who suffer from anemia, the physicians would recommend their patients take iron as a dietary supplement, but taking it along with vitamin C would naturally help them improve the bioavailability of iron. And we also see here the catabolism of tyrosine. So tyrosine is an amino acid, and you see there how vitamin C plays a role in the catabolism of tyrosine. And this information also we have seen how vitamin C is essential in folic acid metabolism. So you see there folic acid is already essential in anemia control, and deficiency of folic acid can give rise to anemia. And you know the anemia that results from loss of iron supplements, although these are two different kinds of anemia, folic acid deficiency leading to one category of anemia and iron deficiency leading to one more category of anemia. And in both the case, you see vitamin C being helpful in addressing the issue of anemia, although both stem from a different etiology. So this could be a common nutrient supplement for people suffering from anemia as a whole. So look at the functions of vitamin C. We are going to revisit a little bit more. We will gradually go into the details of vitamin C. Now you look at this picture, which is depicting the role of vitamin C in the collagen synthesis. So what is collagen? Collagen is a protein very essential in the connective tissues. So it's the main protein substance that all the structural aspects of our body, the connective tissue, are made of. In fact, without collagen, we would become so flexible. In spite of having a bone system, we will not be able to articulate or move our bony skeleton everywhere we want to go. So collagen is the glue that bridges all the connective tissues intact. And for the maintenance of collagen, you need vitamin C. If you look into the previous slide, you have a clue why vitamin C is essential for collagen utilization and collagen build-up and maintenance. So this picture gives you how the role of vitamin C in the hydroxylation of proline and lysine plays an important role. So collagen are all proline-rich proteins. So if you look at this connection of how hydroxylation of proline and lysine are dependent on vitamin C, so there is a natural inclination to look at how this might have an impact on collagen maintenance and collagen repair and collagen replacement. So for people who suffer from inflammatory conditions connected with collagen disease, supplementation with vitamin C could really help them. And we know very well how vitamin C has a kind of immunomodulation function whereby they are able to bridge the development of immune cell proliferation effectively to fight pathogenic invasion. Now, if you are going to associate vitamin C with collagen and structural matrix or protein substances which are essential in the maintenance, vitamin C can be directly linked with its role in the architecture and the credibility of collagen formation and metabolism and maintenance. So for people with inflammatory conditions, you could very well give vitamin C as a supplement to improve the outcome of the therapy. So today we are going to summarize. We saw the source of vitamin C, we saw the structure of vitamin C, we also looked at different functions connected with vitamin C, and we also looked at the overall need of vitamin C in the well-being of connective tissues. So today's summary includes the function of vitamin C, the origin of vitamin C from dietary sources, why we are dependent on vitamin C from dietary sources. The primary reason is we cannot synthesize vitamin C in our human system, especially the primates and mammals are not capable of synthesizing vitamin C, although it comes very close to the metabolic pathway, but we lack those essential enzymes. So we saw about that. Then we saw how we are dependent on dietary source to compensate for this loss. And finally, we finished off with the functions of vitamin C and its role in the maintenance and metabolism of essential components connected with the cellular structural architecture, especially the collagen. I am going to ask you a question: why we have to have dietary supplement of vitamin C? Mention all the essential nutritive sources which are rich in vitamin C, and what is the major role of vitamin C in immune responses, and can we take vitamin C as a prophylactic in preventing infection. You can take down these questions and you can find answers from the standard textbooks. Thank you.